Buongiorno a tutti, sono Gianmaria Ciman di Perfect Wine.
Good morning. My name is Gianmaria Ciman from Perfect Wine, which is a spin-off of the Verona University. It cooperates with the other groups mentioned about the usage of wine coadjuvants in the process of the removal of turbidity from juice separation. And we will focus on the use of decanters for white wines, rosé and red wines. In the case of red wines, the mash is subjected to thermal treatment, which is thermal vinification. Then solids are separated. In our case, we will focus on white wine vinification. The first works about decanters for white vinification dates back to 1981. Since then, decanters have been used in wineries to extract and separate juice from the solid part. The must that was obtained was fairly rich in suspended solids, which means that it had later on to be subjected to juice separation. This means that a process was started with a view of avoiding this additional step. That was achieved thanks to the usage of coadjuvants dosed on mash, which gave a clear must, a clear juice. Here you have a scheme of the white vinification process, starting from the harvesting to destemming, pressing, separation and fermentation. The separation can be done in several ways, by sedimentation, floating, and or other methods, followed by the filtering of the lees. But of course we have criticalities there which are linked to the high labor needs and long times needed for this process itself, and equally high costs. You have then to handle the mash. You also need to devote time and water and additional resources to clean the presses. There is also an issue in terms of low sustainability with reference to the filtering of the lees, which means long time needed to have separation, to have a clear juice, and degradation of quality as a consequence if time is too long, and a huge consumption of resources. The alpha-level food deck centrifuge makes it possible to separate the must from solid parts and obtain a clear juice and have pressed leans. This means a series of advantages: no washing, shorter times, limited handling, no filtering of the lees, more sustainability. In order to have to obtain this result, a decanter is used to extract and separate the juice, but also in order to make it clear. This is made possible by means of decazyme, which is a polyenzyme product with a high activity, pectolytic activity, which is used. And then decagel is added in line before the mash enters the decanter. The dosing of coadjuvants in the industrial process improves it, because you can either increase or diminish the dose depending on the turbidity that you want to achieve. This means that you can also correct things if the turbidity is excessive. You can also do that in progress. This inline dosing system makes it possible to reduce the quantity of coadjuvants which are used, because the formation of the flocks is more efficient, and therefore you will obtain a clearer juice. Coadjuvants which are used in the industrial process have been chosen based on laboratory tests which entailed centrifugation of the mash with a force which is similar to what happens and occurs in a decanter. The tubes with the mash were put in the system, centrifugation was started, and then the surfactant was measured in terms of turbidity. The laboratory tests focused on the usage of enzymes. In this table, you see data about turbidity of the juice after the centrifugation process. You see that the enzymed mash and the control without enzymes after this process have clearly different turbidity levels. You see the numbers there. After 1 hour, 280 NTU for the former, 630 for the latter. If you also add gel, you see that you can even get to 76 NTUs of turbidity. The graph at the bottom of the slide shows that the enzyme time is very interesting, and also quantities are very interesting, because you see that 50-60 minutes enzymatic process entail for these quantities the best results. In the following tests, we assessed different types of gelatins, swine gelatin, but also fish ones. And the technical features will be explained by Dr. D'Andrea later on. What we see there is the performance of these gelatins in terms of obtaining a clear juice. It is not so that they all provide the same results. Hence, the selection of Decagel, which is there in purple. It is gel E, and it has proven to be the best performing gelatin, and that is what we use for our industrial tests. So far, we spoke about laboratory tests. Now we will focus on the monitoring and on data which were obtained in the industrial process. Data were obtained at the Orange River Cellar, Uppington, South Africa in 2014. The graph here depicts a process where no coadjuvant was used, and you see the turbidity of the juice when leaving the decanter. Of course, there are variations, and they are due also to the fact that this is not a homogeneous product, which means that the mash entering the decanter will never display the same content of solid. Sometimes it is more liquid, in other cases it is more solid, so to say, and more difficult to process. What is fundamental and important is to assess the average turbidity of the mash at the end of the process, which in this case is 467 NTU.
The same process was carried out using gelatins and enzymes. Now you can see how we managed to decrease the turbidity at the exit point of the decanter on average to a level of 45. Now, if you want to obtain a very clear must, approximately 20 NTUs, that is possible, that is doable. In the buffer tanker, you have two phenomena. One is flotation, the other is sedimentation or settling. Now, this all happens without using any gas or any other adjuvants. This might become relevant to produce sweet filtrated juices or other types of filtered products. The juice in the pumice was also measured as obtained from the decanter using the usual pneumatic methodology. The juice in the pumice is 63%, with the press it's 61%. But it is important to mention that pumice coming from a decanter is already rich in lees, while in the press they are separated immediately.
In questo grafico
In this chart, you see the must yields. These are pretty comparable between the two pieces of equipment, whereas in the case of the pneumatic press or bladder press, you can obtain a press must or a free-run juice, whereas in the decanter, it's all an undifferentiated batch of juice. Particulates in must was also measured using laser diffraction. In this case, we have two charts. The one on the left-hand side represents musts obtained from decanters and presses at 150 NTUs, while the one on the right-hand chart, again, the same two pieces of equipment, but the level of NTUs is 200. The press is in green, the decanter in blue. In the case of the must at 150 NTUs in a decanter, you have a particle size of 10 NTUs, which is much higher, whereas the particulate in the press is around 100 microns, so it's very different in its quality. In terms of suspended solids and turbidity for fermentation purposes, you get to approximately 150 and 200 NTUs. In the literature, you find references to suspended particles, but a reference is never made to the procedures used to separate the must effectively and clarify it. And also, there is no reference to the methodology used to assess the percentage of solids. It would be interesting, therefore, to better assess this set of data, because a turbidity which is acceptable for us, which is around 150 NTUs in a must obtained using a decanter, might be even higher, 150 or 300 NTUs, and it would be appropriate to obtain a new correlation curves between turbidity and must solids, also because the particles obtained using different techniques, as we've seen, has very different characteristics. In conclusion, the use of adjuvants, enzymes, and gelatins has made it possible to obtain more adequate must turbidity readings in order to directly ferment the must itself, and thus avoiding settling and flotation. When the must obtained using a decanter was too turbid, it is possible to use a continuous flotation using gases just at the exit of the decanter. The must obtained using a decanter is very different in terms of particle size from that obtained from a press. Now, in a future perspective, wherever the vineyards are very far from the winery, 2 to 5 hours or even more longer, it could be a good idea to take decanters closer to the vineyards and equip an area, a yard, to receiving the mash right next to the vineyard, so that the must can be extracted and separated with the decanter, so that limpid, chilled, and inoculated must can be transported to the winery. That would make it easier for the winery to manage the logistics of the must, and that would reduce the use of labor, the time extension, and that would make it all more sustainable from a number of perspectives. So thank you very much, Gianmaria.